All right, let's jump right back in here now that we have a new screen with the same example we were looking at, 3x squared plus 3x plus 5. That was the simplified expression that we created. What I want us to look at now is what happens if we're given an expression and we're asked to evaluate. Let me write this word down. Evaluate by letting x equal 2. Now, evaluate, that's a good vocabulary word. It means that we're going to, and we talked about this earlier, it means that we're going to get a numeric answer. Evaluating an expression means that I'm like plugging a number in, or I'm getting a number result at the end of my problem. So we're going to let x equals 2. What that means is anywhere that there is an x, we're going to put a 2. So I'm going to come to my example here. In the first term, I find an x squared. So I'm going to put, instead of x, I'm going to put 2 squared. Now the reason I'm putting parentheses is just to show that it's not 32 squared, right? I don't want to get us confused later on. So it's not that I'm trying to add parentheses in to make it more complicated. I'm just trying to show that 3 and 2 are different numbers. Okay, I look at the second term. I have 3x, so I'm going to turn that into 3 times 2. So instead of 3x, I have 3 times 2. Plus, my final term is just a 5. So there's no x, there's nothing I can substitute, so I just let it be 5. So I have the same exact equation, except everywhere that there was an x, I'm putting a 2. This is probably lots of review from last year's class, or if it's been a couple years since you took Algebra 1, a couple of years, but just want to make sure we're laying the foundation nice and solid. What does it mean to evaluate? What does it mean to let x equal a number? It means that we replace x with that number. And then we simplify, and we're going to use our order of operations. So let me come back here to show you our awesome chart here. So we have our hierarchy of mathematical operations, starting with the most powerful, which is exponents and roots. Then our next most powerful, or like just a little bit weaker, is multiplication and division. And then lastly, we have addition and subtraction. And the caveat to this is, if there are parentheses, look inside the parentheses and see if there's anything that can be simplified. If there's nothing inside the parentheses that can be simplified, you ignore it. But those parentheses are meant to draw your attention and make sure that everything inside is simplified first. Okay. Parentheses, then we do exponents and roots, multiplication, division, addition, and subtraction. All right, let's look back. Okay, do we have any parentheses? Yes, we have parentheses around the 2 here. Now, is there anything inside that can be simplified? No, it's just a 2. So, can we do anything inside the parentheses? No, we're going to ignore it. Let's move to the next level. Do we have any exponents or roots? Here, yes. We have a squared. We have 2 squared, in fact. So we want to evaluate that first. Remember that a square only affects the number right next to it. It does not affect the 3. The 3 is out here on its own. If we're going to, it's like the taser example. If we're going to zap the 2, it's only going to affect the 2, not the 3. So 2 squared. What is 2 squared? 2 times 2 is 4. So this becomes 3 times 4. I'm going to bring everything else down so we have all of our numbers here. So we have simplified our exponents. Let's say check, we did that. All right, now we ask ourselves, is there any multiplication or division? And if we look at this, we say yes, there are actually 2 locations where there is multiplication, right here and right here. We want to solve these from left to right, kind of like you read from left to right. So, and there is no division, so we don't have to worry about that. So 3 times 4 is 12. Then we move to the right. 3 times 2 is 6. And then we bring everything else down, keep it the same. So now I have, instead of 3 times 4, I have 12. Instead of 3 times 2, I have 6. And then the rest of it is just like we had in the previous category. So this is multiplication and division. Done. Okay, now we ask ourselves, is there any addition or subtraction? Yes, we actually have two addition signs. There's no subtraction here, but even if there was, we would always solve it from left to right like we read. So let's just simplify it, starting with the 12. 12 plus 6 is 18, plus 5, so 18 plus 5 is 23. So the answer to this expression, or when we evaluate this expression with x equals 2, we get an answer of 23. We know we have evaluated, going back up to our vocabulary term here, we know we've evaluated because we get a numeric answer. The answer is 23. So we did our addition and subtraction, check, and now we're done. All right, that should give us a pretty good foundation in talking about expressions, talking about expressions that involve multiple terms, expressions that have numbers, expressions that have symbols or variables, and then what it means to evaluate those to get a numeric answer. We will talk more about this later on in class.